Everyone, we meet again. So today we are going to continue with the last chapter of this semester, application of differentiation, and we are going to focus on the first subtopic for this lecture, which is 10.1 extremum problems. At the end of the lesson, students should be able to, the first one, to find the critical points. The second one is find the relative extremum using the first derivative test. And the third one is to find the relative extremum by using the second derivative test. Means that we can find the relative extremum by using two methods, which is the first derivative test and the second derivative test. And then the last one is to solve optimization problem. Let's check the first learning outcome for today. Extremum problem. What is extremum problem? Okay, in this part, we need to find the critical points of a function for any value of x in the domain. Okay, so what is critical point? So critical points can be found by letting f prime x equal to 0, or f prime x may not be defined. Okay, so what we need to do is to find f prime x. What is f prime x? This is the first derivative of function, so we need to differentiate. And the critical point where f prime x equal to 0 are called stationary point. And the value of the function at that point is a stationary value. Means that the value of x where we substitute into the function. The first derivative test. Suppose that c is a critical number of a function f that is continuous on a to b. So on an interval on a number line, then if f prime x more than 0 for a to c and f prime x less than 0 for c to b, then f has a local maximum at c. Okay, so let's say this is our number line, right? So we have interval a to b, and then we found out that c is the critical number, the value of x, critical x value. And then if we found out that from a to c the f prime is negative, less than 0, more than 0, positive, and then from c to b the f prime x is negative, then it will be going up, going down. So what is c? C is the peak of this, right? So it's a maximum point, local maximum. But if f prime x is less than 0 for a to c and f prime x is more than 0 for c to b, so this is our number line. So this is a to b, and then we found out that c, from a to c the f prime x is negative, and then from c to b the f prime x is positive. So this c is the bottom value, which is it can be the local minimum. So c will be the local minimum. And last one, if f prime x does not change sign, so it's either f prime x more than 0 for a to c and f prime x also more than 0 from c to b, doesn't change the sign, so both are positive, or less than 0 and less than 0, then f has no local extremum at c. So let's see the first derivative test by visualizing the diagrams such as in the figure 3.22. So to look at the local maximum, so let's say this is our graph with c the critical. So we know that f prime x before C is positive, right? So if positive, what it means? So f prime x is actually the derivative, right? So we mean the derivative of a function is actually the gradient of the function. So if f prime x more than 0, the gradient more than 0, so the gradient at a point will going up. So we get positive value, right? So the graph is actually going up. And then if f prime x is less than 0, means that the gradient is going down, negative, right? And then so the graph will be going down. So this point C will be the maximum between these two gradient. Okay? Same as the local minimum. So if we visualizing it, so f prime x less than 0 for C means that negative, it's going down. So the curve will be going down. And then for more than 0, f prime x more than 0, so the gradient will be positive, so it's going up. So this critical C will be the local minimum. Okay, for the no-extremum situation, so if we have the C, means that before C, f prime x can be more than 0, and after C, it will be the same gradient, which is f prime x is more than 0. So the graph will be maybe like this. So both are going up. So we don't have local extremum here. Okay? It can be another situation, which is f prime x. So if f prime x less than 0, it will be like this graph. Okay, so both have gradient of negative going down. So we don't have local extremum here. Let's see the example for this part. So example 1, find the stationary values and stationary point of the curve fx equal to 3x power 4 minus 4x power 3 minus 12x squared plus 5, and determine the nature of that points by using the first derivative test. So we want to find stationary values, stationary point, and determine the nature by using the first derivative test. There are three things we need to find in these questions. So what is our fx? Fx equal to 3x to the power of 4 minus 4x to the power of 3 minus 12x to the power of 2 plus 5. What is the first thing we need to do? Remember, critical point is when f prime x equal to 0 and when f prime x is undefined. So we need to find f prime x. The first step should be finding the f prime x. So what is f prime x? We have to differentiate everything here. So we get 4 multiplied by 3, 12, and then x to the power of n minus 1. So 4 minus 1 is 3. And then 4 multiplied by 3 is 12 also, x squared, and then minus 24x, and then plus 5 will be 0. So this is our f prime x. Now, to find the value of x, because this is a cubic function, so what we need to do? Usually we will have to factorize. So what we can factorize? You can see that everything here have a common factor, which is x and 12. So we can factorize 12x here. So we get x squared minus x minus 2. And then we can factorize this quadratic. It will be x minus 2, x plus 1. So if we want to find the value of x when f prime x equal to 0. So this is the second step to find the value of x. So we just have to equate to 0. 12x minus multiply with x minus 2 multiply with x plus 1 equal to 0. So what is the x that we will find? Yes, x will be equal to 0, or x equal to 2, or x equal to negative 1. Okay, so now we actually found the critical already. But the question asks you to find the critical values. Okay, and then critical points, and then the nature. Okay, so how to find the critical values means that we have to substitute every value x we found. So for x equal to 0, what is f0? So substitute the value into the original function, we get 5. And then for x equal to 2, we get negative 27. For x equal to negative 1, we get 0. So what are the stationary values. So we have the value 5, negative 27 and 0. So we need to give the answer as the stationary values equal to negative 5, negative 27 and 0. And then the next question is to find the critical points. So we have to write down in point form. So what we get is, for x equal to 0, the y is equal to 5, right? So the point will be 0, 5, and 2, negative 27, and negative 1, 0. So this is the two questions they asked in the example. What the third question? To state the nature of the points. So let's do that. So if we have f prime x equal to 12x multiplied with x minus 2 multiplied with x plus 1, then we can check the value of f prime x for each of the criticals. Okay, the easiest way to represent this is to use the table. Okay, so what is the interval we should have? So because we have 3 criticals, means that we should have 4 intervals separated by the 3 criticals. So what is the smallest value? It should be following the increasing order. So the smallest value is negative 1. So the interval before negative 1. Okay, so we have negative 1, we have 0, and we have 2. So what is the first interval? It should be from negative infinity to negative 1. The second interval will be from negative 1 to 0. And the next one is from 0 to 2. And the last one should be more than 2. Okay, now we can take any value in this interval to check the value of f prime x. So for the first interval, we can take negative 2. For second interval, we can take negative 0.5. For the third interval, we can take 1. And the last interval, we can take 3. So this value is just an example. You just need to choose any value in the interval. So this is my choice. Okay. So next, what we need to do is to substitute all this value into the f prime x to check whether it's positive or negative. So after we substitute everything, so for negative 2, so this one negative, this one is negative, this one is negative. So the multiplication between 3 negative will be negative. And then for the second one, what I will get is this one will be negative, this one will be negative, and the last one will be positive, 1 minus 0.5. So if positive means that positive, negative, negative, positive, positive, positive will be positive. And the next one is if we substitute 1. So we get positive here. This one is negative. This one is positive. So it will be positive, negative, sorry. And the last one is if we substitute 3 in this value. So 3, this is positive. This one is also positive. This one is also positive. So it will be positive. So what is the conclusion? So if we get the sign here, we can sketch. Okay, conclusion negative. So kalau negative, decreasing. So it will be going down. And then this one, it will be positive, means it will be increasing. And then this one will be negative, decreasing again. So positive is increasing. So what is this point when x equal to negative 1? Not 0, sorry. So this is negative 1. So it will be, yes, it will be minimum point. How about x equal to 0? Maximum point. And then when x equal to 2, so it will be minimum point. So we can do the conclusion that the nature of these 3 points is that 0, 5 will be the minimum points, and negative 1, 0, and 2, negative 27 will be the minimum point. Okay, 0, 5 maximum point, negative 1, 0, 2, negative 27 will be minimum points. Okay. Example 2. Find the critical numbers and determine the relative extremum of fx equal to 9 over 5x to the power of 5 over 3 minus 18 of x to the power of 2 over 3. So we need to find the critical numbers only and then the relative extremum. Okay. So, the same as the first example. What we need to do to find the extremum value? The extremum value. So we have fx equal to 9 over 5x power of 5 over 3 minus 18 of x power of 2 over 3. The first step we need to do is, yes, to find the f prime x. So differentiate this function, what we get is 3 of x power of 2 over 3 minus 12x power of negative 1 over 3. And then what we need to do, we have to equate to 0 lah. But before that, we can simplify this expression, this function first. So what we can do is, we can see that we can factorize 3, and then this x also can be factorized. Which one x should be factorized? The smallest one. So we can factorize x power of negative 1 over 3. Okay, why we need to factorize? Because we have to make sure that no value of x is ignored. Okay, if we just cancel out everything, then we will take only one value of x, so it's not complete. That's why we need to factorize and maintain the x. Okay, so now we have 3 of x power of negative 1 over 3 multiplied with x minus 4. So equate this to 0. So what is x power of negative 1 over 3? It will be x power of 1 over 3. Okay, the second step, when f prime x equal to 0. So what is the critical? It's critical when we have the f prime x equal to 0 and when f prime x is not defined. So what it means by not defined? Remember how the function will be not defined? When the denominator equal to 0, when the value inside set will be negative, and when we have logarithm of a negative value and 0. Okay, so what is the value of x here? For f prime x equal to 0, we know that x will be equal to 4. And when f prime x is not defined is when, yes, the denominator equal to 0, means that when x equal to 0. So the critical numbers will be 4 and 0. So the number is the value of x. Okay, so we have two values of 4 and 0. Now we have found the critical number. What we need to do? The second question asks you to find the extremum, right? So let's do that to find the extremum. Okay, so the next part of the question is to determine the relative extremum of the critical numbers. So what we need to do, we can use the table to show it. So what are the interval we can have in the values? So because we have two criticals, so we can have 3 intervals. So the first interval will be from negative infinity to infinity to 0, and then the second one is from 0 to 4, and then the last one will be 4 to infinity. Now we choose any value in this interval, and then we substitute into the f prime x. So if this negative to the power of negative will be negative, this one also will be negative. So what is the sign? It will be positive. And then the second one, we substitute the value, what we get is a positive and then negative, so it will be negative. And then the last one, if we substitute the value, we get positive and positive, so it will be positive. So the conclusion, we get increasing, decreasing, and increasing. So what are the extremum of x equal to 0? It will be maximum point, and then for x equal to 4, it will be minimum point. So to find the extremum, so we need to find what is the value at x at the critical number. So when x equal to 0, fx equal to 0. When x equal to 4, f4 is equal to negative 27.2. So we have these 2 points, so we can conclude that therefore 0, 0 is the maximum point, and then negative 4 negative 27.2 will be the minimum point. So that's all for example 2. Okay, so the next part of this chapter, this lecture, is to determine the critical point and by using the second derivative test. So suppose that f double prime x, so f double prime x is the second derivative of f, is continuous on an open interval that contains c, the criticals. Then if f prime x equal to 0 and f double prime x more than 0, then f has a local minimum. So it's the double derivative of f is positive when we substitute the value of c, then we have a local minimum. But if it's less than 0, then we have a local maximum. If it's equal to 0, then the test has failed. So we don't have the conclusion here. Thus, we need to use the first derivative test. So if the second derivative test is failed, then we need to use the first derivative test to check. Okay. The example, by using the second derivative test, find the relative extremum of fx equal to x cubed minus 3x squared minus 24x plus 32. So what we need to do, the first step, it should be, yes, to find the f prime x. So differentiate fx, we get 3x squared minus 6x minus 24. And then what we need to do, the next step is, yes, we just have to factorize and equate to 0. So factorize this one, we can factorize 3. And then we get x squared minus 2x minus 8. And then we can factorize x squared minus 2x minus 8. It will be x minus 4, x plus 2. Okay. So then we need to find the value of x by equating f prime x with 0. This is the second step. So equate 3 multiplied with x plus 2, x minus 4 equal to 0. So we get two values of x which is equal to negative 2 and 4. So now we found the extremum, the critical numbers already. And then because we want to check the determine, so we need to find the second derivative. By using the second derivative, so the third step is to find the second derivative of f, which is equal to, from here to here, we get 6x minus 6. So to check to determine the extremum problem, the extremum, so what we need to do is just substitute both of the values, the critical numbers. So we get of f double prime negative 2 equal to negative 18, which is less than 0. What we can conclude? Yes, this is a maximum point, maximum numbers. And then for f double prime of 4, so we get 18, which is more than 0. So 4 will be the minimum, local minimum. So what is the conclusion? We need to find the critical points. So because we have only x now, we need to find what is f2. So what is f negative 2? So we get f negative 2, substitute into the original function fx, we get 60. And then when x equal to 4, we get f4 equal to negative 48. So the conclusion will be negative 260, the point negative 260 will be the relative maximum, and the point 4 negative 48 will be the relative minimum. Okay, done. The last part of this lecture is optimum problems. To solve the optimization, so these are the steps that we can use to solve the optimization problem. The first one is to identify the variable to be maximized and minimized. So what is our target? We need to identify it first. And then the second one is to express y into a single variable function. So y equal to dot 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 dot. So y into a independent variables, another independent variables, let's say y equal to fx. And then the third one is to solve, means that, yes, to find the critical numbers lah. And then the next one is to verify the solution. So if the solution maximum or minimum, so we have to verify that it is the one we want to find. Okay, either it's maximum or minimum. Okay, we can use second derivative because it will be easier. Okay, and the last one is to get the optimum value of y equal to fx. So we know the value of the critical numbers here. Now we want to find the value, so the value of y lah. So we just need to substitute and give the answers. Okay, let's do some example. Example 4. So this is the real life situation. So we have to interpret the problems here to identify what are we going to find. Okay, an open top box is to be made by cutting small congruent squares from the corners of the 12 cm by 12 cm sheet of tin and bending up the sides. How large should the squares cut from the corners to be to make the box hold as much as possible. Okay, let's interpret the questions. So we have this 12 by 12 cm sheet of tin. So it's a square sheet, right? So what we need to do, we want to get a open top box. So we need to cut the side so that we can bend up this side to get a box, open box. Okay, so this is what we understand. So this one is open. Okay, so the question is, how large should the squares cut from the corners? So this part, how much we need to cut, right? So we need to cut the same size lah. This side is the same size, this one also the same size, because we want a square. That's why we can represent the side here will be x. And then to make the box hold as much as possible, means that we want maximum volume of the box. Okay. So what is the first step we need to find? Okay, we have to identify the problem here. So let's say this is an open box. So after we bend up the tin, what we get is this form of box. So the side here will be x, because we want to cut out x, so it will be x lah. So everything here will be x. This one also will be x. So if this x, so what is this can be represent as? Okay, because we know the total of the sheet, so the origin is 12 by 12, right? So we have to cut out this side. So how many? This one is x, this one is x. This is equivalent to 12 minus of the 2x. Okay, so to find the volume, so we have to represent volume in x, right? So how large should the square cut the corners? Means that it will be x. And then the volume of the box, make the box hold as much as possible. So we need to find what is the volume. So we can represent the problem by the volume. What is the volume? Multiply the length, the width, and the height. So it will be 12 minus 2x multiply with 12 minus 2x multiply with x. Okay, and then what we need to do? Just simplify to get the expression here, which is 4x cubed minus 48x squared plus 144x. And then what is the next step? So we have identified, we have represent the function we want to find, which is the volume. And then the next step is to solve. How to solve? What we need to do is to maximize the volume. Means that we have to find the first derivative of the volume. So differentiate v. So we get 12x squared minus 96x plus 144. And then solve it to find the value of x here. So we can equate to 0. So after we factorize, what we get is 12 multiplied with x minus 2 multiplied with x minus 6 equal to 0. So what are the critical numbers here? We get x equal to 2 and x equal to 6. So what is the next step? To verify. We need to verify whether it's maximized or minimized. Okay, depending on the question. So what we need to find is the first step should be the second derivative test lah. So we have to differentiate the volume. So what we get, so for the second derivative, we get 24x minus 26. So check for both critical numbers. So when x equal to 2, we substitute into the second derivative, we get negative 48, which is less than 0. Means that will be maximized. And then when x equal to 6, so we substitute value and we get the second derivative equal to 48, which is more than 0. So it will be minimized. So which one we should use? Yes, when x equal to 2, because it will be maximizing the volume. So the conclusion will be, therefore volume will be maximized when x equal to 2. Okay, let's say the question asks you what is the maximum value the box can hold, means that we just have to substitute the value of 2 into the function of Vx. Okay. Example 5, the last example. So, you have been asked to design a 1 liter oil can shape like a right circular cylinder. So, you have to know how to draw or imagine the right circular cylinder. Which dimension will use the least material? The least material. So, how can we build the least material? Means that we want to build a 1 liter oil can shape, right? So it will be a cylinder, right circular cylinder. So we have right circular means that we have circular as the cross section of the cylinder, right circular. It's not it's not an ellipse or anything, not an oblong or anything. It will be the right circular. And then, so to build this 1 liter oil can shape, so it should be going to be the surface area, right? Right. Okay, it's not volume, but it's surface area because we want to build in. So we have the top one and the bottom one circle. And then we have this body. Okay, this body, if we open it, it will be a not square but rectangle. Okay, so now we need to find what are the functions or the problem we need to solve. We want to find the least material, means that we want to find the smallest surface area we need to use to build the 1 liter oil can shape. Okay, so now the first thing we need to do is identify the problem. So we want to find which dimension, we want to find the least material, right? So it say which dimension we use the least material. So first we have to recognize what are the variable we can use here. So we have circle, means that we have to represent in terms of r. And then for cylinder, we have the height of the cylinder, which is h. Okay, now we have two variable, right? Now, to find the least material means that we have to find the surface area for this can. So what we will get? Okay, so remember the surface area for circle. What is surface area for circle? So this is our r. So the surface area will be pi r square, right? Okay, so if pi r square is the surface area for circle, we have two circles. That's why we have 2 pi r square, because multiply by 2 circles. And then to find this area, the surface area for the body, what we need to find is, it's actually in the form of rectangle. So we have the height, which is equal to h, and then this side, the length, will be what? So it's actually the circumference of the circle. So how to find the circumference of the circle? It's actually the 2 pi r formula. So that's why we have 2 pi r h here for the surface area. Okay, but we need to represent the area in one variable only. So we need to replace this h in terms of r. So what we can do? Okay, because we know the volume is equal to 1 liter coin. Okay, so what is volume for cylinder? It will be 2 pi r, so pi r squared h, right? The cross section is pi r squared. Okay, the surface area, and then we multiply for h time. That's why pi r squared h equal to 1000 milliliter. And then what we need to do? We can represent h in terms of r, which is equal to 1000 divided by pi r squared. So we just have to replace h into the area formula, which is equal to 2 pi r squared plus 2 pi r of 1000 divided by pi r squared. So we can simplify this one. We get a equal to 2 pi r squared plus 2000 divided by r, which is r to the power of -1. So now what we need to do? The third one is to solve, to find the value of r and then to check. Okay, find the value of r. How to find the value of r? We need to define the first derivative of a first. Okay, so differentiate A respect to R, we get 4 pi R plus negative 2000 of R to the power of negative 2. And then we need to equate to 0. So how to solve for this one? Remember, we have to consider every value of R, whether when f prime x equal to 0 or f prime x is undefined. Okay, so that's why we need to find the common denominator for this one. We need to remember that we cannot eliminate any value of R. Please consider every value of R. That's why we have, after we find the common denominator here, we have 4 pi R cubed minus 2000 divided by R squared equal to 0. So we will have, it's either 4 pi R cubed minus 2000 equal to 0, where R cubed will be 2000 over 4 pi. So R equal to cube root of 500 divided by pi. Or for when the dA over dr undefined is when R equal to 0. Okay, so the next step is to verify whether the critical number we found is the minimum or maximum. Okay, so what we need to do by using the second derivative test means that we have to differentiate for the second time. So we have d squared a over dr squared equal to 4 pi minus 2000 multiplied with negative of r negative 3. So simplify, we get 4 pi plus 4000 power of multiplied with r to the power of negative 3. So what we need to do, we just substitute the value when r equal to 5.42. Okay, remember that I said earlier we get, so r equal to 0, right? But how can we get 0? Because we want to find some radius. If not, we don't have anything if r equal to 0, right? So we just take this one value, r equal to 5.42. So when r equal to 5.42, substitute into the second derivative, what we get is 37.69. Means that it is more than 0. So it will be minimizing the surface area. Okay, so what we should do for the last one is to do the conclusion. And then we know the dimension we should use is r and h. So we need to find what is the value of h when r equal to 5.42. So h is equal to 1000 over pi multiplied with r squared, right? So substitute r equal to 5.42, we get h equal to 10.84. So our dimension for r here equal to 5.42, and for h here will be 10.84. So the conclusion is, therefore, what are the dimension, right? So therefore, r equal to 5.42 and h equal to 10.84 is the dimension, are the dimension that we will use to find the least material to build a 1 liter oil can. Okay, so that's all for the optimization problem. So to interpret the situation, it will take time, but we know the steps that we can follow to solve it. Okay, so please read the question properly and relate the problem we need to solve. Okay, so that's all for the first subtopic of this lecture. Thank you.